Troubleshooting RIP Next Generation. I can't help but have a smile spread across my face every single time I say that name. Nonetheless, this is our RIP Next Generation flyby. IPv6 network setup. You can see the major network 2001 DB8 6783 with the subnet identifier of X, and I've got all these little subnets that fill in that X as we go around the network. Now, I've also gone in here and given the IP address, the actual host identifier, based on the router number. So, for instance, router 1 is going to be 2001 DB8 6783 122::1. This guy, where are we? Over here is also going to be .1. This guy's going to be .2, and so on and so on and so on. Does this make sense? So the first thing I want to do is, because IPv6 is not as familiar to everybody as IPv4 typically, I'm going to do a quick verification of the configuration. I've got my router 1 sitting right here. I'll do a show IPv6 interface brief, if I could type that. And you can see that they've got their link local addresses already selected. You can see the IP addresses that have been assigned to each interface, just like I was describing above. I also, if I do a show run include IPv6, I have ensured that every single one of these routers have the command IPv6 unicast routing. Easy one to forget and will cause things to fall apart quickly. Okay, now, how do we start the RIP process? Well, it's two steps, really. You go into global configuration mode on each one of these routers and type in IPv6 router RIP, and then you give it a name. We'll call it CBT RIP, right? It is case sensitive. That actually goes into the configuration mode for the process itself. You can see there's not a ton of commands here, but there are some global commands that apply to this. Thankfully, though, in everything IPv6, the configuration of the network command has disappeared. You can see there's no network command. It's all gone under the interface, which is so much better and more logical. So on router 1, I'm going to go into fast Ethernet 0/0 and do the command IPv6 RIP followed by the name of that process that I created. So I'll say CBT RIP. Hopefully that's not rest in peace. CBT RIP, and then we'll type in enable. And I hit enter. It's now enabled on that interface. I'll hit the up arrow and do serial 0/0. Enable. That's it. We go to every single one of these routers and do that same command. And by the way, we don't have to have the same. Here, let's just automate our process the best we can, right? We'll go in and paste this guy right here. Global command into Notepad, and then we'll go under, because I'm looking, just about every single one of the interfaces are the same, so we'll go under serial 0/0 and we'll do IPv6 CBT RIP enabled, and then we'll just do the copy and paste of that into fast Ethernet 0/0, right? And then it is that easy. I'm going to go to router 2, config T, paste. Router 3, config T. And I know, you're looking at me going, there is no fast Ethernet on router 3 down there. That's alright. It's shut down. It'll be okay. So we've got all those in place, and then ISP, Sure. Since we have access to the ISP, let's enable RIP on their router too. Oh, I lost my clipboard. Maybe it wasn't meant to be. Nonetheless, we've got RIP enabled all over the place. Let's verify this is all working okay now. I've got router 1. I'll do a show IPv6 route. And from router 1's perspective, I think the only network that is not local is going to be this 121 right here. So that should be the only one it sees, and it does, via RIP anyway. 121 learned via RIP, so Let's hop down to router 3 where we can see a few more, right? I'll do a show IPv6 route, and we see the two RIP networks, 122 and 123, both the WAN link right here and this LAN link that router 3 has learned about from there. Good. Okay. What about the default route? I mean, if the ISP weren't participating in RIP, how would we advertise the default route using RIP next generation? Well, process is somewhat similar to the old version of RIP with a major difference. I'm going to do a default route. Let's do IPv6 route. Default route in IPv6 world is :/0, right? And then the next hop IP address, so that'll be 2001 :DB8 :6783 we are 122, and I know I made the ISP .4. So 122::4. There's our default route. So I'll back out here, just do a show IPv6 route, and verify that we do now have that default route sitting in our table. Okay. Let's go into now the interface. Now this is the difference. In the IPv4 version of RIP, essentially when we went under the router RIPed and used the default information originate command, which means it applies globally to wherever the RIP protocol is running, whereas this one is now on a per interface basis. So that's kind of cool because I can say, well, I don't want to send a default route on that interface, but I do want to send it on that interface. I didn't have that flexibility in the old RIP version for RIP, the old RIP. So I'm going to go into interface. Let's do fast Ethernet 0/0. Now again, perspective here, I'm going under the interface. I want to send the default route out of. I know that's terrible English, but hopefully you catch it. So then I'm going to do IPv6 RIP. All right, the name of the process will be CBT RIP. And I'll say the command is now default information originate, and just hit the enter key because it'll set its own metric. Hit the Control Z command, and now let's head over to who would get that router 2. So let's do a show IPv6 route. Give it a sec. It is RIP. I know we call it next generation. Oh, there we go. Okay. But it's still slow, right? So we've got RIP default route showing up right there. It started with a metric of 1 since I did not set a metric, and you can see it's now saying, okay, well, it's 2 coming away from me, and if I go down to the router 3, that should propagate its whole way down. You can see 3 hops away from router 3. With a protocol that simple, what could possibly go wrong? Well, thankfully not that much, but some things to be aware of. First off, make sure that IPv6 unicast routing is enabled. In the real world, you wouldn't get very far without this being turned on, but remember, we're in the T-shoot exam where something could be tossed on a router far, far away that you have to kind of dig and find out. It doesn't hurt at all to go onto a router and go into global config mode and type in IPv6 unicast routing. If you ever are curious or not sure if it's been enabled, that will enable it, and that makes sure that routing is actually happening. Second thing is make sure that you do not have an ACL blocking RIP in any way, shape, or form. RIPng uses UDP 521. The old RIP version, I keep saying RIP version 4, we'll just call it the original IPv4 RIP, right? Used UDP 520 since it's a totally different protocol. They decided to move the port number up one so it would not be confused as to being compatible with this RIP next generation. Last most common thing that could happen is you don't enable the interface. You need to actually go into the interface and use the IPv6 RIP command to enable it for the RIP routing process. You can see all the show commands that I have on here. I think I've showed, well, some of these. Let's make sure I hit them all. Show IPv6 RIP database. This is kind of your view into all the routes that are being learned from the RIP process. Essentially every route that the RIP process knows about. And you can see the default route in there that we're advertising as well. I can do a show IPv6 protocols. Now, you might remember the show IP protocols from the IPv4 version. This is in no way as informative as the old show IP protocols used to be. It just says, hey, I'm running RIP CBT RIP and it is running on these interfaces. Thank you for playing. You really have to type in show IPv6 RIP and then that name, CBT RIP, to see more of the show IP protocols command, or what it used to be, where you get the port number, you get the administrative distance, the multicast group that this is sending messages for. I mean, essentially all the nitty-gritty details of this can be seen using the show IPv6 RIP command rather than the show IPv6 protocols. Protocols just shows which ones are enabled and where they're enabled. Finally, I'm going to do a debug IPv6 RIP, which will show all the messages happening as they are happening. So give it 30 seconds or some increment therein, and we should see some output occur. There we go. We've got messages coming from the neighboring routers. Notice all the neighboring routers are communicating using what? Their link local address, because they all do that with every routing protocol. They use that for local communication to their neighbors. You can see all the different routes that are being advertised coming in from those different neighbors and what metrics they have. You are now able to troubleshoot RIP Next Generation. I hope this has been informative for you, and I'd like to thank you for viewing.